All right, so a review from last week. We started talking about the axis of symmetry. The axis of symmetry is like a mirror. It divides this parabola into two equal pieces, and all of the points mirror each other. And that's wonderful because when we go to graph these parabolas and you find a point over here, you've actually found 2 points. You go, the same distance from the mirror line, from the axis of symmetry, to the other side. You have 2 points for the price of 1. You only have to do work for 1 point, and you have 2 points. The axis of symmetry, when it's in vertex form, when we have f of x equals a parentheses x minus h squared plus k, the vertex is hk. And remember I told you the axis of symmetry is always x equals whatever is in the x spot of the vertex. So this axis of symmetry, x equals h. Every time, x equals. What we're going to do today is we're going to graph equations. We'll start out by graphing an equation that is in vertex form. But we want to do the least amount of work as possible. So if we understand vertex form, we're going to have a lot less work than just plugging in a bunch of numbers and eventually connecting them. So the first thing I want you to do is find the axis of symmetry and find the vertex. We're going to find that first. Since it is vertex form, we're going to find our vertex first. This is what you did for homework. What is the vertex in this form? What is it? -3, +4. Remember, the x is always opposite. The y is that k on the outside. Don't graph it yet. Don't graph it yet. Then our axis of symmetry is always, if you say it, if you participate, you're going to remember it better. And this is stuff you have to have memorized. So the axis of symmetry is always x equals, and then for this one it is what? -3. Now, the next thing we are going to find is the y-intercept. And we will graph it in a moment. But the reason why I'm finding information first is because sometimes all of our information does not fit on our graph. And when we go to graph it, we want to adjust our graph to fit our information. So let's find our information first. How do we find the y-intercept always and forever? Every time you do it. How do you find the x-intercept? What do I mean by the y-intercept? What is that on the graph? Where is it? It's on the y-axis. And what is the same about every single ordered pair on the y-axis? What is the same about every single ordered pair on that y-axis? If you're looking at every ordered pair. X is 0. So to find the y-intercept, you plug in 0 for x. But since we are doing functions, and because we are in Algebra 2, we have to learn this function notation. So when I plug in 0 for x, that is the same thing as saying f of 0. So that means wherever you see an x, replace it with 0 in the equation. Wherever I see an x, make it 0. So here's my equation up here. Wherever I see an x, make it 0. So -2. 0 plus 3 squared plus 4. Wherever I see an x, I made it 0. And then on this side, f of 0, that's the same thing as y. That is the same thing as y over here. It's just when x is 0, what is y? So on this side, on the right side, that's the only side I do anything to. I just have to find what that number is. So order of operations, what do we do first? Parentheses. So inside parentheses, 0 plus 3. Okay, then what do I do next? Exponent. So the exponent is on just the 3. So we have -2 times 3 squared is 9 plus 4. So we have -2 times 9 is -18 plus 4. I'm going to add those together, negative 14. So our y-intercept is the ordered pair, 0, negative 14. So why didn't I graph it yet? Because, yeah, I already knew that was going to be off the graph. So when we go to graph this one, 0, negative 14 is really far off the graph. So I'm just going to adjust my scale. To adjust your scale, you have to let your teacher or anybody else reading your work know that something happened. If you don't show me that your scale was adjusted, I think you graphed it wrong. So what you're going to do is, since our y's have to go to 0, negative 14, on my y-axis, I think I'm going to count by 2's instead. I do not have to label every single y. Just label a few so your teacher can see your pattern. Okay, and then I can figure it out what you're counting by. Now, do I have to change my x-axis if I change my y? You do not have to. You may if you want. I don't want to, but you can if you want. If I'm not changing my axis, if I'm just counting by ones, I don't do anything to it. If I'm changing it, I gotta put some numbers on. So now I'm going to graph my vertex at negative 3, 4. So I didn't change my x's, negative 3, and then up to 4. There's my vertex, negative 3, 4. My axis of symmetry is x equals negative 3. Now my y-intercept is 0, negative 14. And remember, I'm counting by 2, so negative 2, 4, 6, 8, 10, 12. Negative 14 is here. When you are graphing parabolas, when you're graphing quadratics, I expect to see minimally, the least amount, 5 points before you start connecting them. 5 points. How many points do you see me having right now? 2. So I still need 3 more. But the wonderful thing is that this graph is symmetrical. So when I find my y-intercept, it's 3 away from that center reflection line. So if I go 3 the other direction, I have a 3rd point on my graph. I only have to find 2 more points. And at this point, there's nothing else to do to find them. You can just plug in any x you want and find the y and graph it. So we're going to be smart about it, though. We want something that is going to be on the graph. This is our center point, the vertex. So maybe pick something on either side of it. And we don't want to pick x as 0 because I already know that answer. We don't want to pick x as negative 6 because I already know that answer. So give me a number to pick for x to plug in to find the rest of the graph. Give me a number for x. What? Well, 1's like all the way out here, and that could easily be way down there. Wait, before we go on, that's okay. Before we go on, how do I know the graph's going this way? How do we know the graph's opening down? How do we know the graph's opening down? The negative in front tells us that there is a reflection in the x-axis. So we should know that the general shape of it's going to be opening down. Okay, so what number could I plug in? Negative 1? Or maybe negative 2? Either of those would be fine. We'll plug in negative 1. So when we plug in negative 1, we do f of negative 1. I mean, it's in the equation. Wherever I see an x, make it negative 1. So negative 2, parenthesis, there's my x, negative 1, plus 3, close parenthesis squared, plus 4. I just plugged it into the original equation, replaced x with negative 1. Then I do order of operations. So I do the parentheses first. Then I square. Then I multiply. And then I add. Ordered pair is negative 1, 4. Negative 4, I mean. Negative 1, negative 4. Oh, I counted by twos though, didn't I? -1, -4. Remember I counted by twos? Maybe I should have labeled that down there. Now, if I have that point, I actually have 2 points. Reflection point, less work. Reflection point, 2 away. And then when you connect your dots, it should look like a U shape, not a V shape. It should not come to a point at the vertex. It should round through the vertex. Goes rounded through the vertex. If you are ready to go on to the page, so I know you're ready to go on, make sure it does not look like a V. And we're going to look at number 2. We're going to look at number 2 on the next page. Number 1, if you are working ahead of me and get done with number 2, then you can try number 1 also, but we're just going to do number 2. We're going to find the vertex, we're going to find the axis symmetry, we're going to find our y-intercept, and we'll find any extra points we need to find to graph it. How many points should we have on the graph? Minimally 5. I think 5 more, but minimally 5. So first of all, start with our vertex. Vertex is 2, 5. We use our H and we do opposite of our H, and then we use our K. So AOS, axis symmetry, X equals the X part of the vertex, 2. So if you have your vertex, then you have your axis symmetry. Y-intercept, how do we find the y-intercept? How do we do it? We plug in 0 for x. So we're going to do f of 0. We're going to plug in 0 into our equation for x. 2 times 0 minus 2, quantity squared, plus 5. Then we use our order of operations. So as we start to graph this, are we going to be off our graph? Should we renumber something? Okay, so I'm going to renumber my x's. I'm going to keep my x's the same. I'm going to renumber my y's, so I'm just counting by 2's on the y-axis. I'll go 2, 8, 10, 12, 14, so there's 13 there. 0, 13. What's our vertex? 2, 5? 2, 5. Axis symmetry is there at 2. Mirror point to the y-intercept. It's the same distance away at the same height. And I have 3 points. I need 5. What should I plug in that I haven't already found the answer for? Which x should I plug in that's somewhere around our vertex, but it can't be 2 because I already know that one, can't be 4, can't be 0. What should I plug in? Okay. Yeah, that sounds good. Let's plug in 1. And I'm running short on space. I might have to go underneath that. I'll just use this spot over here. We'll do f of 1. So wherever I see a 1 in the equation, wherever I see an x, make it a 1. So 2 times 1 squared plus 5. Order of operations, 1, 7. Now, once you have that point graphed 1, 7, you also have its mirror point, so you have more points. And that would give you 5. And you can make sure it looks like a U. Make sure it looks like a U. All right, you guys sick of vertex form? Sick of transformations? Are you ready to move on to something different? Nothing? Well, we're about to move on to something different. So half of your homework is going to be what we just did, graphing when it's in vertex form. Half of the homework is going to be just like this. The other half is going to be the stuff we're about to do. Okay. Part of the algebra curriculum says that we are supposed to derive the formulas for the axis of symmetry and the vertex and the y-intercept from vertex form when it's in this new form we're about to do. So that's part of the curriculum, says that you are to derive the formulas. We're going to do it as a class instead of you doing it individually. We're going to do it as a class once. And then once we've done it, then you'll know why the formulas exist, and then you just memorize the formulas, okay? Okay. So you don't have to memorize what we're about to do. You just copy it down so you've done it, and then you have to memorize the answers. So what we're going to do is we're going to work in what's called standard form the rest of the day today. Standard form is f of x equals ax squared plus bx plus c. It is quadratic still, but it is when you take the vertex form and you simplify it. That's when you take the vertex form and you get rid of the parentheses and combine like terms. That becomes standard form. We like vertex form because you can find the vertex quick and you can find the transformations real fast. Standard form, you can find other things quick. In standard form, you can't find the vertex very fast. So usually vertex form is better, but we have to know how to do it in every form. So first of all, you're going to write kind of small, because there's not a lot of space there. We're going to take f of x equals a parenthesis x minus h squared plus k, and we're going to expand it. We're going to simplify it. We're going to get rid of the parentheses. So order of operations, what do you do first? What is order of operations? First. Parentheses. Inside the parentheses, can I take x minus h? Cannot, because they're both variables, they're not like terms. Next in order of operations is exponents. So the exponent is on x minus h. It says square that. We talked about it last time. How do you square that? Jessica, how do we do it? Write it twice, and then how do we multiply it? Distribute, or the FOIL method. So that's our first step. X minus h times x minus h. We're going to FOIL that. First, x times x, x squared. Outer. Minus hx. Inner, minus hx. Last is negative x times, or negative h times negative h is positive h squared. And we combine like terms, and the like terms are the middle two terms. They both have the same variables. So if you have minus 1 and minus 1, you have minus how many? Minus 2. So we're going to have a parenthesis x squared minus 2hx plus h squared, and then close parenthesis plus k. So I just brought down the a and the k from before. Still not simplified because we still have parentheses. So what do we do next? After we square it, then what do we do? Order of operations. Multiplication, division, which we have a multiplication right here. Distribute. So I just multiplied all three of those terms by a. Just put it next to everything because it's all letters. And then we look for any like terms. Like terms have to have the same variables to the same exponents. Do we have any like terms? Any terms have the same variables to the same exponents? So then this is simplified. So now what I want you to do is I want you to compare this back to standard form, which they wrote out. In the very first term, do you see how ax squared is, so what we did is we took vertex form and multiplied it out. But if you multiply it out, it is standard form. Do you see how the first term is exactly the same? These are the same. The middle term, the middle term is, for the black one is negative 2ahx, and for the blue one is plus bx. You'll see that they both have an x. So one of them has negative 2ah, the other has b. And then the last term is this whole ah squared plus k and c. Those are the same terms. So I'm going to put dual screen here, and we're going to fill out that where the blanks are. Okay. So these are the observations we are making. In the first term, since it's ax squared and ax squared, what does a equal? If the first term is ax squared, what does a equal in the second term? Like, they're the same. What does a equal? A equals, I'm not making sense, am I? I'm not doing a good job right now. Are they different at all? No. They both have x squared, they both have a, so we're going to say a is a. A is the same as a. For both forms, for vertex form and standard form, a is a. And what does a normally tell us about the parabola? What's that number in front tell us when it's in vertex form? Stretch or shrink or reflection. So a in vertex form tells us the exact same thing that it does in standard form. If it's a negative number, it's going to be a reflection. If it's a number bigger than 1, it's going to be a bigger than 1 vertical stretch, right? It's going to be the same stuff. Now b is a little different because b is different. So b is equal to negative 2ah. But when we use vertex form, the h is what the axis of symmetry is in vertex form. So I'm going to do this big over here so you can see what I'm doing. You probably have space to do it over there. It says solve for h to obtain h equals. So what we're going to do is we're going to say b equals negative 2ah. And we're going to solve this equation so it says h equals. How do I get rid of negative 2a if it's next to the h? How do I get rid of it if it's next to it? What operation is next to? If you can't see it, it's multiplication, right? If it's next to. So how do I cancel out multiply by negative 2a? Divide by negative 2a both sides. And then we simplify. We never leave a negative in the denominator. So what I'm going to say is h is equal to negative b over 2a. That's what goes in that blank. The next line, so the axis of symmetry is x equals negative b over 2a. That is the formula for the axis of symmetry. And we just derived it, so now you can memorize it and always use it. You don't have to derive it anymore. You did it as a class, you just have to memorize and use it. What is the axis of symmetry? X equals negative b over 2a. How are you going to memorize it? By listening to me say it. Try it again. What's the axis of symmetry? X equals negative b over 2a. Now we're going to say it with enthusiasm because this is so much fun. Ready? I'll say it with you. Ready? X equals negative b over 2a. All right. Last one is C. C is equal to AH squared plus K. Now it tells you here in vertex form, if we do f of 0, that's how we find the y-intercept. You do f of 0, you will have left over AH squared plus K. You do f of 0. So AH squared plus K is the y-intercept, otherwise known as C is the y-intercept. C is the y-intercept. C is the y-intercept in standard form. On the next page, it has this all summarized. So the next page is actually stuff you need to memorize. You don't have to derive this before. The next page, the important information would be the A value tells you if there's a stretch or a shrink. The A value tells you if it opens up or down. That's what the A value tells you. The axis of symmetry is x equals negative b over 2a. X equals negative b over 2a. That's the axis of symmetry. We are going to have to find the vertex. Look at the vertex. Look how fun that looks. Here's the vertex. Does that look fun? Remember, the vertex, the first number is always the same as the axis of symmetry. So negative b over 2a is also that x part of the vertex. And then what does it mean if I do f of negative b over 2a? What does that mean? If I have f of something. Every time we see an x, replace it with that number. So whatever number that is, just put it into the equation. We'll do that in just a moment. So this looks like a lot of work. It's not. It's whatever that number is, put it there. And then take that same number, plug it in for x in the equation to find the y. That's what that says. And then the y-intercept is C. So the point 0, C is that y-intercept on the parabola, 0, C. So these are memorize, memorize, memorize. Now let's do an example. F of x equals 3x squared minus 6x plus 1. First thing, what form is this in? Standard form. So we have to use the stuff we're memorizing for standard form. So the first thing you're going to find is AOS. X is let's try that again. Yeah, it's negative b over 2a. X is negative b over 2a. We'll practice. So negative b over 2a. So in the equation, that is ax squared plus bx plus c, we have to do negative b over 2a. We have to do negative, what is b? It is with the sign negative 6. So we're doing negative negative 6 over 2 times, what is a? 3. So I'm going to simplify that. That's going to give me negative negative 6 is positive 6. 2 times 3 is positive 6. What's my axis of symmetry? X equals 1. Vertex. The formula says negative b over 2a, comma, f of negative b over 2a. The formula means whatever that number was that we just found, do f of that number in the equation. So I'm doing f of what number? What's this number right here? Negative b over 2a. What number did I get? David? 1. Excellent. So I'm going to do f of 1. In my original equation, wherever I see an x, replace it with a 1. So 3 parenthesis 1 squared minus 6 parenthesis 1 plus 1. And simplify. 3 times 1 minus 6 times 1 plus 1. Negative 2. So the vertex is 1 comma negative 2. The x we input and the y we got out. We put in 1, we got out negative 2. Next we find, what did we find next every time? We did it on the first few examples. Y-intercept, thank you. And so to find the y-intercept, we do f of 0. We plug in 0 for x. We plug in 0 for x. We do f of 0. 3 parentheses 0 squared minus 6 times 0 plus 1. But you may have just learned a shortcut. And when it is in standard form, The y-intercept is always what? On that previous page. Y-intercept is what? Ready to go back? What's the y-intercept? Oh, it's on this page. 0, C. So when you do plug in 0 for f of 0, when you do plug in 0, that cancels out, we just get 1. So we get 0, 1, which is 0, C. You see that last number with 1? That only works for standard form. Now let's graph what we have. We have the vertex at, or the AOS at x equals 1. Our vertex is at 1, negative 2. Our y-intercept is at 0, 1. You can find a mirror point. How many points do I have graphed? 3? How many do I need? So I need to plug in one more point. What should I plug in for x? That's going to be easy to find one more point. I can't plug in 0, I can't plug in 1, I can't plug in 2. What should I plug in? 3? Or maybe negative 1, depending if you want to do a 1 or it's got a negative with it, or if you just want to do a 3. Totally up to you. I'll do 3. I think more mistakes happen with negative numbers. So we'll do f of 3. We're going to plug in 3 every place you see an x. So we get 27 minus 18 plus 1. 9 plus 1 is 10. So plug in f of 3 and I get 10. Plot 3, 10, and then find the mirror point. Plot 3, 10, find the mirror point. Make sure it looks like a U, not a V, when you connect all the points. Make sure it looks like a U. Takes practice. Someday you can be as perfect as mine. Joking, because mine weren't perfect. Steer it doesn't sound right. Can you look at the next page? Let's find the axis of symmetry and vertex one more time. We practiced the y-intercept a bunch, but let's find the axis of symmetry and vertex one more time. What's the formula? X equals... Let's try that again. X equals... You want a solo? Anybody who's not saying anything. You want a solo? All right, try it together as a class. X equals... Oh, if you don't know it, you got to say it every time. Negative b over 2a. It has to be memorized. Don't come to me the day of the test like, did we get like a formula sheet? Because I never memorized. Memorize. What? You guys are in a big boy and big girl class. Okay. And this is like 3 letters, negative b over 2a. You can do it. And then from there, you just have to plug it in. All right. So x equals negative b over 2a. What do we got? X equals negative, what is b? What is b? 2 over 2 times what is a? What is in front of the x squared? 1. So we have x equals, what do we get? Negative 2 over 2? Negative 1. That's our axis of symmetry. Then how do we find our vertex? We do f of negative 1. We plug in negative 1 for x. We do negative 1 squared plus 2 times negative 1 minus 1. And write it as an ordered pair. Negative 1 comma negative 2 is our vertex. And what's our y-intercept? What's our y-intercept? Plug in 0. What's our y-intercept? What's our y-intercept? 0, negative 1. You just plug in 0 and you get C, negative 1. What's our y-intercept for this one? 0, 1. Okay. Our assignment is in the book, and there are graphs. So I'm going to hand out some graph paper. And got to make sure that if you don't have your book at home, that you either take a picture of it before you leave, or take your book home. And there's 8 graphs, but there's no backs to this, so you're going to have to take 2 pages. Sorry. Make sure you take 2 pages because there's no backs on this. You only have to take one. If there's a back on it, you just need one. If there's a back on it, you just need one. Some of them didn't. That's what I just said. So you guys only need one. These have backs. Where's my extra? So if yours has backs on them, you just need one. You need 8 total. So you already got one. You just need 8 total. The 15 to 18 is matching. So the first 4 graphs and the last 4 graphs. There's 4 of them vertex form and 4 of them standard form. What do you do if you got questions? How are you going to ask? You can come before school, let out. Study hall 4th.